global economy is driven by data. Very common thing between econometrics and data, big data analytics is data. Both economists and data scientists deal with data. So we must have clarity or about some important concepts or terms before examining the need for the convergence between econometrics and big data analytics. You know what is an economy? An economy is a system where people are employed and struggling, fighting hard to earn the scarce means. That's all. Whether it is global economy or national economy or regional economy. Since resources are scarce, the world is competitive. So it is linked with our wants, you know that. It differs at different levels. For an individual, it is maximization of utility. At a firm or company level, it is maximization of profit. For government, it is welfare. So both are same. Whether it is, and it is mainly for rationalization and nothing else. We are all selfish, and as that selfishness is for survival, that is biological. We need not examine what is inside the brain. Let us think of it, econometrics and big data analytics. As I said, the common thing between these two disciplines is data. So you know what is data. Unless you know and clearly understand the term data, you cannot think of the convergence between these two disciplines. Data means there are phenomena or facts. Facts may be inflation or trade war or any economic phenomena. Like that, we find different types of facts in our physical world. But we don't want to make the analysis of the facts or phenomena in our physical world except our economy. That is the difference between big data analytics and econometrics. So data is nothing but numerical information about fact. For example, it is inflation. If you collect numerical information about that inflation, then it becomes data. So both of us, whether it is data scientists or econometricians, they deal with data. That is the common thing where we can find the scope for the combination or convergence between these two disciplines. Both the disciplines are treated as STEM. Both the disciplines are STEM disciplines. That is STEM, you know, you are all familiar with STEM. STEM education, STEM component in all branches of knowledge is must for our survival or decision making in the global economy. STEM means science, engineering, then science, S, science, T, technology, E, engineering, and mathematics. These components are there, or in econometrics, we find these components in econometrics and big data analytics. So that is the similarity between these two branches of knowledge. So there is more demand. There is more demand for chartered data scientists and chartered economists in the global economy. So the present conventional econometrics is not suitable.
Sir, slide move ಆಗ್ತಿಲ್ಲ ಸರ್ ನಿಮ್ದು.
Okay. let me give some introduction, then we can go to the slide. What is our problem in the economy? Whether it is economy or any society or a business environment, our problem is rationalization. We are all bundle of desires. Our goal either is for maximization of utility or maximization of profit or maximization of welfare, depending upon the situation, whether it is individual or firm or government. So our problem in this scarce system is to make decision. Then what is decision? Decision, there are, if you want to do certain things, there will be alternative courses of action. Choosing a particular course of action in our environment to achieve our goal, reach our goal, is called decision making. Decision making is universal, whether it is data science or econometrics. So, and that comes under rationalization. Now, we can think of it, econometrics and what it is and why it is and how it can be linked with data science or big data analytics. So, you know what is econometrics? Econometrics is a branch of economics which deals with data using economic theory and mathematics and tools of statistics with computer to analyze the information obtained in a given situation for effective decision making. That's all. That is what econometrics is. So, you know, we use economic theory and try to build econometric models using the tools of econometrics. So, what are the steps? What are the steps in building economic models? You are all familiar with the different steps involved in econometrics. That is, first one is hypothesis formulation. We have to use you have to draw some hypothesis, formulate hypothesis for a given environment, whether it is inflation, trade, balance of payment, we don't know. Situation differs. First, we should start our analysis with hypothesis. Hypothesis may be theory. If it is theory, you have to test whether it is true or false. If it is not theory, you have to draw some assumptions called hypothesis. Formulation of hypothesis is the first step in building econometric model. Then we go to collection of data. Data is must. Collection of data. There are different tools, you know, whether it is time series data, maybe time series data, cross-section data, panel data. There are different types of data and different sources. We collect data regarding our hypothesis. Then we translate the data, collected data, we classify and tabulate those data, and then we try to identify a function, whether it is linear function or non-linear function in it. And after carefully examining the function in a given situation and identifying the dependent and independent variables with constant, then we build mathematical model. That is what we do in econometrics. After building a mathematical model, you know, our subject involves error term because it is, our brain is uncertain. Unlike physical sciences, we have to face the problem of errors in our models. That's why we have to translate that mathematical model into econometric models with stochastic variable or error term. Then building of econometric models. Once we build econometric model, then we go to estimate parameters. Parameters, we have to calculate the constant and coefficient of variables, independent variables, and then we can think of using that model for testing or decision making. After estimation of parameters using OLS, ordinary least square method, or a maximum likelihood, there are different methods in econometrics. Then we go for specification, model specification, whether the model is good or not, that we have to confirm. After running the model and finding it fit for the analysis, fit for running, then we go to test our hypothesis. This testing of hypothesis or running of model is for policy decisions. Policy decisions are different at different levels, individual or firm or government. These are all the key steps in the formulation of econometric model. Here we have to apply this model for to study the consumer behavior and market analysis and forecasting, policy formulation and forecasting of that situation. Facts, that this is how we use build economic model and apply econometric model for policy decisions. So I hope you are all familiar with econometrics, but I doubt whether you are all familiar with big data analytics. So here, we deal with data. Let me go to big data analytics. What is big data analytics? So you know what is computer. What is computer? Computer is an electronic machine. For what? For collecting data, inputs, and then storing the same, and then analyzing the same, and then interpreting the same for policy decisions. Decisions of what is the policy decision? Maximization of utility or maximization of profit or welfare, economic welfare. That is our goal. So, what is data science? Data science is a multidisciplinary field that uses scientific method, algorithms. They write algorithms. Step by step procedure is called algorithms. And the system is computer. To extract knowledge and insight from data, don't forget. They are dealing with data. We are also dealing with data. It involves collecting, cleaning, analyzing, interpreting large amount of data to uncover hidden patterns, trends, and relationships that exist that can be used to inform decisions and predictions. So, what they are doing, big data analysts, what they do, they are collecting, cleaning, analyzing, interpreting large amount of data. For what? For what? To uncover the pattern, trends, and relationship from the data. Data, data collected from different sources contains some pattern, hidden pattern, and trends and relationship. Although that is most important for us for policy decisions. So you know what is decision? Choosing a particular course of action among several alternative courses of action is called decision. Essentially, data science, what they do, what big data analytics do in their system is they turn raw data into actionable data. That is what we are also doing the same thing. Then let us go to big data analytics. It involves using computational techniques, machine learning to analyze massive, complex, and diverse data sets. So you know what is artificial intelligence and IoT, Internet of Things. Artificial intelligence, what is artificial intelligence? So the discussion all over the world, current discussion all over the world would be on artificial intelligence. It is going to bombard our global economy, national economy, and everything. So artificial intelligence means it makes a computer to mimic human beings, our brain. And it is going to uh, mimic human brain. That is called artificial intelligence. Artificial intelligence is very important in big data analytics, where we are going to use different computational techniques, machine learning, and deal with complex and diverse data sets. So here the difference is they use computer scientists or data scientists use supervised data, unsupervised data, and semi-supervised data. And instead of using statistical tools directly, they have developed machine language. Machine language is the subset of artificial intelligence. Machine language is making revolution in the field of big data analytics. It makes things easy in artificial intelligence. They can use statistical tools and learn and make a system to function well in data analysis. And in the same way, there is deep learning, machine learning, and deep learning. Deep learning, again, is a subset of machine learning. Artificial intelligence is superset of machine learning. Machine learning is the superset of deep learning. Here, things goes like this. They did all of the whether the layer is AI or machine language or deep learning, they use data, complex and massive data for analysis and decision making. So there are one more thing is there, that is a natural language processing, NLP, and that is going to bridge the gap between machine language and deep learning, machine learning and deep learning, and that is also one of the wonderful inventions in big data analytics. Anyway, they are using statistical tools, mathematics, probability, calculus, and all sophisticated tools of statistics for data analysis using computers. So, our goal, whether it is econometrics or big data analysis, we have a common goal. We deal with one thing, common thing, that is data. And that data analysis, we both of us are doing data analysis for one purpose. What is the purpose? What is our purpose? Purpose is analyze, classification, analysis, and interpretation of data for policy decisions. That's all. Purpose is same. Output is also same. We use the conclusion or a pattern of data obtained after the careful analysis of numerical or factual information for policy decisions. That's all. That is what we do. Purpose is same. Only thing is method is different. Ours is traditional method. We use economic theory and we think of only economic problems and we try to find solution to the economic problems related to scarce means and unlimited ones. That is what we do in economics. But the scope of big data analytics is vast. It covers many things, many fields, whether it is physical science or space science or anything for that matter. It covers many things and collect information and analyze the same for decision making in different fields of branches of knowledge. Anyway, So, you can understand what is big data analytics or data scientist, data science and econometrics. You know the difference between conceptual difference between econometrics and big data analytics. So the tools here, the tools of big data analytics are machine learning. Machine learning, as I said, is a subset of artificial intelligence that enables computers to learn from data without explicit. They don't need it. They don't write programs directly. It Machine learning helps the big data scientist uh, to learn data without programming. That is the speciality of machine learning. Machine learning is full of statistical tools, nothing but else. Regression analysis, right? Correlation, like that. Probability, it knows all these things. This machine learning is very useful for data scientist to make computer to function for to analyze data and provide solution to the problems without programs. That is the speciality of machine learning. And then deep learning. Deep learning is again is a subset of machine learning that utilizes artificial neural network. How our brain works, functions. There are trillions of neurons in our brain. And you know how the brain functions. Like that, so computer scientists or data scientists try to develop deep learning. Deep learning means they want to make system, computers, to function like our brain using deep learning. In deep learning, they can process images, text, and audios, unlike our numerical data. They can process data like data like images, text, and audios, and with more accuracy, and try to uh, extract the patterns in those images for policy decisions. That is the speciality of deep learning. Natural language processing, NLP. This is field of intelligence, artificial intelligence, that focuses on enabling computers to understand, interpret, and generate human language. See, human language. There are thousands of languages all over the world. We can translate that human languages into a language the system can understand. NLP. NLP combines deep learning and machine learning and helps us for human communication and machine understanding. It bridges the gap between human communication and machine understanding, allowing computer to process information in a meaningful and context. Context. Okay. Key aspects of data science. What we do in data science, the same thing as we do in economics. Collection of data, data cleaning and preparation, exploratory data analysis, visualization and reporting, and deployment and monitoring. In a sense, data science is about using data to understand the world around us and make better decisions in various fields, from business and healthcare to the science and engineering. This is the similarity between the methods of econometrics and the steps involved in data analytics. Let us examine the relationship between big data analytics and econometrics. Data science and econometrics are two fields that have a lot in common, but also have their own distinct features and challenges. They are complementary with each other, and their role in data analysis is same. Data. Both of us deal with data. You know what is data. Econometrics and big data analytics are treated as STEM disciplines. So this is common all over the world. Without STEM component, our discipline cannot become relevant in the modern world. If you want our subject more relevant and prominent for decision making, we have to think of STEM component. Econometrics is considered as STEM discipline on par with big data analytics. This is common thing. Both of them are decision-making science with different tools, whether it is econometrics or big data analytics. Our goal, output is same. We use both the tools of econometrics and big data analytics for decision making. You know what is decision making? Decision making is choosing a particular course of action among several alternative courses is called decision making. Decision making is for what for? Rationalization. Rationalization is nothing but if you are an individual, it is for utility maximization. For me is after cost minimization, profit maximization. If it is a government or local government, what is their goal?
Welfare.
Thereafter, resources are scarce. Thereafter, maximizing welfare, social welfare, community welfare. That's all. Let us examine the difference between these two fields. They use data to understand the world around us to make better decisions in various fields, from business and healthcare to science and engineering. What is the scope? Econometrics is specialized branch of economics focused on economic phenomena, whereas data science is a broader field encompassing various types of data analysis across many disciplines. That I have already explained. It covers all the disciplines. Big data analytics is useful for all branches of knowledge. Econometrics is restricted to confined to economic problems. That's all. Technique. Data science often employs machine learning, artificial intelligence, and computer programming to analyze big data and find hidden patterns. Data contains patterns, There are hidden patterns, attributes. We have to uncover the patterns from data. For policy decisions, data science, what they do in data science, they use machine learning, artificial intelligence, computer programming to examine huge mass data and uncover the pattern from it. What we do in econometrics, while using statistics, focuses more on established economic models and causal inferences. In economics, we give more importance to cause and effect relationship. We try to find the cause for a given phenomena. Unlike in big data and in data scientists, their goal is prediction. Their goal is to uncover the pattern from data for policy decisions. They think they give least importance to examine the cause and effect relationship in a given situation. That is the technique where we find the difference between econometrics and big data analytics. Application. When you go to application, when you examine application, econometrics is particularly valuable in economics, finance, and public policy for understanding specific economic questions and guiding policy changes. Data science has a wider range of application from e-commerce to healthcare. It is wider. Scope is wide, unlike economics. So the scope of econometrics is limited to our economy, but data science covers many aspects of our system. This is the difference between big data analytics and econometrics. What is our conclusion? We know the conceptual clarity I have given. You know what is econometrics and how it is different from big data analytics. So, after the careful examination of the situation, the need for the convergence between econometrics and big data analytics, we have to uncover the pattern from our analysis, right? Like data, after the review of available literature on econometrics and big data analytics, we have to arrive at some conclusion, What is our conclusion? Econometrics provide theory-driven models that explain why relationship exists in data. Okay, cause and effect relationship. We find more scope for cause and effect relationship in econometrics. Based on that, we are going to suggest measures for economic problems. BDA, Big Data Analytics, provides computational tools to handle huge and complex data sets. Data sets are very huge in big data. We use data set is not as huge as in big data analytics in econometrics. So, we deal with huge and complex data sets in big data analytics, unlike econometrics. That is the difference. Big data analytics can feed econometric models with richer and more granular data. Both can improve forecast accuracy. If we converge these two things, these two disciplines, it will be more useful for effective decision making. Our decision making is linked with scarce myths and the goal of maximization, because we are all selfish. We are after maximizing things in the system. We don't know why we are selfish. It is genetic. Our cell is selfish. That's why we are selfish, right? We never examine why wants are unlimited inside the brain. That is all because of cell decision and nothing else. Selfish gene. Now, the question is, we can raise many issues regarding the convergence between econometrics and big data analytics. Is econometrics like data science? Can we answer this question? Can we consider econometrics on par with big data analytics? Is there any link between econometrics and big data analytics? That link lies in fact that both deal with data-driven analysis with different traditions. That's all. What is our purpose? Purpose is to extract meaningful insight from data. Whether you may be an econometrician or data scientist. What is your purpose? Your purpose is to extract meaningful insight from the data collected from different sources. Sources are different. We as economists collect data from the records, fields, primary data, secondary data. There are different sources and different forms of data. Unlike our conventional data, in big data analytics, they use supervised data, that is time series data, and unsupervised data, that is in the form of images, text, sounds like that. That can also be considered as data and that can be converted into information. And then semi-supervised, it is like pool data, semi-supervised data they use. Anyway, their goal is to extract meaningful, uncover patterns from the data. That's all, for policy decisions. What is the core activity between these two disciplines? Core activity is collection, cleaning, analyzing, interpreting quantitative data. Of course, in the data analytics, they deal with qualitative data also. Unlike economists, we use dummy variables, dummy variable models to examine qualitative data. And there is improvement in big data analytics. They deal with huge data, unlike econometrician. And when if you converge econometrics with big data analytics, we can make wonders in the coming days. Outcome, what is the outcome? Both seek to uncover patterns, relationship, and causal effects from the data. You might be big data analyst, data scientist, or econometrician. Your goal is to uncover patterns, attributes, relationship, and causal effect, relationship between variables in a given situation. These are the common things. Now, after the examination of the available literature on these two disciplines, we can raise some questions. What is the future of economics in the era of AI? AI, as experts affect almost 40% of jobs around the world, according to the International Monetary Fund. It will increase global GDP by $7 trillion, as per the prediction of Goldman Sachs. There is no answer for this. These are all the issues before the econometrician. Will economists be needed in future? That's an important thing. If they develop IoT, if they use artificial intelligence for the analysis of given economic problems, inflation, working of stock market, like that, demand, supply. If they can build models, they can build IoT like models. IoT is Internet of Things, small model, subset of artificial intelligence. What will be the fate of economists? Are they useful? If AI is going to replace conventional economist, what will happen? That we have to think. Employment of economics is projected. Still, employment of economics is projected to grow 5% from 2023 to 2033, about as fast as the average of for all occupations. For other occupations, still there is scope for economists. This is the idea from experts. What do economists think of AI? Although AI may at first boost productivity, its long-term impact will be to commoditize skill and automate tasks. You are an economist. You have a skill of examining data and building model. If that skill is commoditized, if that skill is converted into commodity and automate using AI techniques, what will happen? That we have to think. There is no answer for this. We have to discuss all these things before our forum and make our economists as data scientists taking some policy decisions in higher education. Will economics be replaced by AI? That is also an important issue. While AI is rapidly advancing and will undoubtedly transform the field of economics, it is highly unlikely to completely replace human economists in the near future. It cannot completely replace economists. AI can augment their capabilities by automating tasks like data analysis and forecasting, but human expertise, judgment, and creativity in economic theory and policy remains crucial. We cannot ignore all these things. Human expertise, that is going to change. Judgment is subjective. AI has no common sense, Computer has no common sense. These are all creative. AI is not creative. Okay, these are all issues to be examined seriously. So, what is our conclusion? Big data And this convergence with econometrics is the need of the hour for effective predictions and decisions, policy decisions. Now, the floor is open.